questions, analysis, where you need some ideas like that. That's one of the fastest way of revising the syllabus. So I'm still waiting for those who are in the ground floor. And Victor also, Indomie stand. Michael, thank you also for the production of the question. Very fast, great guy. I'm grateful, Anita. Okay, I think we have to start. We'll wait for Thank God, Divine, and a few of you in the ground floor. I don't want to see anybody under the canopy, in front of the talk shop. So if you're not doing chemistry, you may decide to leave the school. So let me have the remaining questions. Okay, let's I'll be timing you. Very important. Time is important. Okay, now let's start with question number 21 to 30. You have 10 minutes. Do it as if you are doing exam. 21 to 30. 10 minutes. Don't worry. Even if you don't know them, the goal is to teach you after when you see question like this next time, how to solve it. '21 to 30. You will not get that diagram for 21, but let me sketch it. That one of the things Mr. Amos taught you recently. So that diagram, don't be waiting for diagrams. Go to the other question. So at 8C, what you have at 8C is 10. This is solubility. So at 80 is 10. And at 60 is 8. This is 60. So this one is 8. And another one, 6. This is 2. 4. This is 6. This is 40. 70, yeah. 50. 40. 30. 20. 10. We don't need all those ones. But the crucial one that we need are those ones on the screen. Daniel, please. What is the next one? But let them go through. 4 minutes more. 21 to 30. Okay, you still get. Let me give that girl. Two minutes, 50 seconds left. Okay, thank you. How many did you? Reach 20. Ah. So, Alan, there are some questions again here. Some of you that are still looking for question. Thank you. Just pass it. If you still need question, please come forward here. We have few questions left from the hot room. How many? Okay. Eh? So you need a question. We still have questions here. Whenever you to avoid is your personal question. Can go back to it again later. How many? Sorry. Do your work. Don't be looking at people. Do your work. Time will soon be over now. Those who are sharing with, tell them, go and buy your own. There are extra copy now. Tell them. 400. Time up. Okay, so that's the end of the time. 10 minutes. It's not too much. Professor Amos has taught solubility, so and he explained to you solubility curve very well. What we are interested in the question is the two temperature and the number of moles of solute that dissolve. Like now we have at 60, we have 8 moles dissolve, and then at 80, we have 10 moles dissolve. So number of moles of solutes, that crystallize out, number of moles of solutes that crystallize out. So what you just have to do is to subtract. At 80 degrees Celsius, 10 moles of the solute dissolve. And then at 60, 8 moles dissolve. So that means number of moles that will crystallize. Just subtract. That's the method every time. 10 minus 8. And that will be 2 moles. What's the name of the salt they mentioned? Sodium chloride. Sodium is 23 IV. Chlorine is 35 points. So what would that give us? Gram per mole. So they're asking for what? What mass deposited. So we know that number of moles is what class? Number of moles is mass over, that's it. Mass over molar mass. Mass over molar mass. So the number of moles they give us is 2 moles. The mass we don't know. Molar mass 58.5. So the answer is 1 what? That's the answer. 117 gram. 117. Hey, why are you okay? 117. You may not get it before, but look at it. That's how to solve it. All question on how much mass of solid crystallize out. That's it. Get the 2 number of moles, subtract, multiply by molar mass. That's all. No big deal. So even if you miss it now, you see tomorrow, you should get it. 22. Solution with the lowest pH value is what? You've not done acids and salts, but we have been coming to class. I've given formula for pH many times. So our pH, is it 22? pH is always minus logarithm of what class? H plus. Now, your pH does not depend on volume. All those volume, 5 mil, that's not our business. We don't need that one for pH. We are concerned about how much hydrogen ion concentration you have. So 5 mil of that one is not our business. 10 mil of that one is not our business. 15 mil, 20 mil, that's not our business. Our business is how much concentration of hydrogen ion do you have. So option A. Option A. They give us M over 10 ACl. Mr. Dan, what does that mean? It means 0.1 molar ACl. That's what it means. Because 1 over 10 is 0.1. Option B also the same thing. M over 10 ACl. What's M over 10? I can't hear you. 0.1. So the 2 of them will have the same pH. So it can't be the answer. The 2 of them are wrong. I'll work it out for you. Because we cannot have 2 answers. This is the hydrogen ion. Forget about the 5 and the 10 they give you. That does not affect pH. What's our C? M over what? M over 5 ACl. What's M over 5? 0.2. Abi? ACl. What's the last one? M over 8. What's M over 8? 0.125. Abi now? Now, anytime you have 0.0, if you don't want to work it in the exam, the biggest of the value has the lowest pH. I repeat, the biggest of the value has the lowest pH. Of these 3 now, which one is the biggest? 0.2. So that's the answer. But let's work it so that we'll not be confused. You can find it, but there is no need. The biggest of the 0 points. Now, pH is minus log hydrogen ion. So this one will give us minus log 0.1. Calculator, what is minus log 0.1? Is that 1? Is 1, Abby? If you press your calculator, you get it. That's A. So A gave us 1. B also gave us 1 because they have the same value. Abby now, let's do for C. pH minus log of 0.2. Who has calculator? 0.693, Abby? Or 699? 699. That's the pH. Then D, pH minus log 0.125. What do you get? 0.90. So which of them has the smallest? 1, 0.699, and 0.9031. Which one is the smallest? That's it. So that's C. That's pH. The one that has the lowest. In finding pH, we are concerned with hydrogen ion concentration. You know, and if all of them have 0 points like that, by sigma, 0 point, 0 point, 0 point, 0 point. The biggest of the 0 points is the answer. So in the exam hall, if you see that, just pick 0.2. That means tomorrow, if I have 0.8 molar, that's the answer I will pick. If I have 0.9 molar, that's the answer I will pick. You know, that's it. So the answer is C. You can see 0.699 is smaller than this one and smaller than this one. Number 23. See, this is my pain. And number 23, I solved it in your class. This same question. In medical class last week, Thursday. Was it Wednesday? Thursday. And you'll be shocked that 79% of you in medical class did not solve it. And I solved this same question. Copper iodide. I solved it. The same. And as some students who were in the class that day, they didn't solve the question, they just got the answer, just pick the answer. Mr. Nas has solved this one for us now. This is the answer. They've so much read and listened in class that they got it without working. And if it's not the one, it's close. It's not the one, Abby. It's the same question. The same question. And many people cannot solve it. And the meaning of that is that the effort on that Thursday was a waste. So that's it too. So we will jump it. So the first thing to do is to write the equation, copper iodide. That's 2. So we write the equation, iron equation. So I have Cu2 plus and IO3. Have you now? 2 minus. 2 minus. Minus. Because you have a 2 here. And then you put 2 here. Iodide. That's it. 2 of these guys, so you have to put 2 here. Mr. Nas, how do you get this minus? Yeah, because this guy is having 2 here. For you to have 2, that means the 2 is coming from this one. You know, if you have 2 like this, Cu2 plus, and you have iodide like this, minus, it's like swapping. You come here, you come here. So I'm going to have Cu1, and then you have IO3, then you must have 2. So this guy is going to have minus 1. To find solubility products, I can say your value x, this again x, this again 2x. When I was solving this on Thursday, I never knew it will come out today. That's why every question you are treating in class, take them seriously. Look at that. So how do you get 2x? There's a limited product because the mentioned product, the one at the front, Cu2 plus, iodides, IO3 minus, you must put power 2. So why? Because of these 2 here. So our solubility products, This one will now be x. This one 2x. All squared. You can see the power 2. So limited product x times 4s squared. So limited product will now be 4s power 3. Meanwhile, the value they give you is what? 1.08 minus 7. So you have 4s keep. I can readjust them. 108 times power minus 9. And some people got it. Do you know what they did? They went to open the note and check it and copy it. That's poor reading method. So you move it 1, 2. That's minus 9. From there, now I have s keep. What would that be? 108 minus 9 all over 4. S keep, is that 27? Then minus 9. Our s will now be keep roots of 27. That's minus 9. Keep root of 27 is 3. And this one is minus 3. That's the answer. That's solubility product. I didn't do that for the engineering student because they were not part of the revision for that one. So look at the solution. Interesting question. 24. Entropy. What does entropy does? Measure degree of what? What of entropy? Its content. So the answer is what? Yeah. You should not miss that one. No. 25. Sulfur oxide plus oxygen give us over 6 oxide. That's contact process, Abby. In the chemical reaction above, the substance that will increase the rate of production of SO2 is what? Vanadium 5. If it is ABAP process where we are producing ammonia, what catalyst do we use? Very good. 26. N2O4, the nitrogen tetraoxide, give us nitrogen 4 oxide. 1 molecule for left, 2 molecule for right. Increase in total pressure. When you increase pressure, it will favor the side that has lower number of molecule. So when you increase the pressure, the reaction above will produce more of NO2. No. Convert all of N2O4 to NO2. No. The answer is D. Mr. Ram, that's my confusion. Then meet people. Or you see me, if I'm free, I can explain that. When you increase pressure, it will go to the side having lower value. And the left is having lower value. And if you want to be sincere, if I ask people to raise their hand now, you see that many people got it. So meet some people, ask questions. There was one of the greatest footballers now in the world now. His name is Vinicius Jr. When he got to Madrid, he was a solo player, selfish, not be dribbling. He would dribble and dribble and dribble and dribble the ghost post. And people were complaining. But now he has become a complete player. People were talking to him. People were encouraging him, you know. So get from people. Don't just sit down and say, I don't understand. It's not clear. And you are in the hostel and you have people who are scholars around you. Can't ask them, even as a day student. 27. What quantum of electricity will liberate 0.125 mole of oxygen? Anytime oxygen is liberated, we have said it before. What quantum of electricity will be liberated? 0.125 mole. There is a reaction every time. 4 hydroxyl, 2 water, plus oxygen, plus 4 moles of electron. So we're going to have 4 Faraday. 4 Faraday equals 1 mole of oxygen. That's it too. And then our Faraday means 96,500 coulombs. This is the reaction. Anytime you hear oxygen liberated electrolysis, this is 1 mole of oxygen. 4 times this one, what are you going to have? 386,000 coulomb, 1 mole. And then what are we given? What quantum electricity? You're going to have X 0.125 moles. Like boom, boom. So our X now is 0.125 times 386,000. Is that correct? Oh, yeah, multiply what do you get? 250 Abi. So I use a different method, no problem. Just get it. In the exam, you will get it. So get it. Number 28. S plus Y give us Z. The rate equation for the chemical reaction above is this. Now, overall order minus delta change in X. That's the rate of reaction. You have K, S power 2, and then Y. Just like saying Y power 1. If there's no power, it means 1. So our overall order, you just add the powers. That's all. The answer is 2 plus 1. What's the answer? 3. Can you see that? That's overall order. Those chemistry is add. It's simple. And then the one you are being taught, try to know them. Try to know them. 29. When a current I was passed through an electrolyte solution for 40 minutes, a mass S gram of univalent metal was deposited at the cathode. What mass of the metal will be deposited when a current of 2I? We have done that something like that in physics, Abi. '29. Faraday's law of electrolysis. First law. Mass 1 over what? Equals what? I1 T1 over what? We've done it. What's mass 1? X. What's mass 2? We don't know. What's current 1? I. What's time 1? 40 minutes. What's current 2? 2I. Time 2. 10 minutes. No need to convert, then go cancel. S over M2. If I 0 cancel 0, no be so. 2 here, 1 here, 2. Is 2 left? Is the answer S over 2? That's the answer. You may not be getting all, but the one you are getting, you are happy. Now, nobody taught me, and I got it. It may be very few, but in the exam, it will be very many. You know, but at least that confidence I can do something on my own. Work on that. 30. RS, AQS plus HF. AQS can give us RF, solid plus HS, AQS, delta H minus 65.7 kilonjoule per mole. From the equation above, it can be deduced that the heat content of the reactant is lower than that of the product. Don't forget that our delta H is always HP minus what? The H. HP minus HR. So for the value to be negative, for the value to be negative, it means the heat of the product must be less than the heat of the reactant. Option A, heat of the reactant is lower than the heat of the product. That's not true. B, heat content of the reactants is higher than that of the product. That's the answer, B. The answer is B. The answer is B. Let's go now, 1 to 10. 10 minutes. Never mind, you didn't score many. Never mind, just learn. Note some of those things. They repeat questions. 1 to 10, 10 minutes. Mr. Dale, please open the gate for those who want to go. Don't stop them, please. Open the gate. It's one. Okay, it should be true. 10 minutes. Gone. So you can see that your challenges are still on stoichiometry. You can't do calculation. That's your problem. So that means you can now begin to look at the area of your weaknesses and what can you do to improve on those areas. Question 1. 200 cm cube of each of 0.1 molar solution of lead 2 nitrate and hydrochloric acid were mixed. Assume that lead 2 chloride is completely insoluble. Calculate the mass of lead 2 chloride that will be precipitated. Can you imagine? Look up. That's what they call emotional intelligence. What we call intelligent quotient. And there's another one we call emotional intelligence, EI. And then we have what we call emotional quotient. Emotional intelligence is the ability of someone to withstand shock, to control his mind or her mind. For example, we're not praying for that. Imagine you enter exam hall and your first chemistry question is this number 1. No, wait. I'm not just talking like that. It's not about God forbid. God forbid. God does not forbid. Now, if you don't have what we call EQ, emotional quotient and emotional intelligence, you may be disturbed. The content of question 1 can affect the remaining 39 questions. And that's why you have to be strong. But somebody with emotional quotient, what will he do? Say, now only 1. That's the only 1 question there. If I don't know that one, I go know the remaining 39. That is the spirit. If you don't have that spirit, then you're in trouble. Because your first question matters. And that's why in the exam hall, the first subject you will do of the 4 matters. Nobody say compulsory you must do English. So in Adam said, I will just come and say, okay, do English first. Why? Because we want to have access to your answer first and use that before you are through and all that. So in the exam hall, what my daughter, Mistura, is going to do in terms of the subject I will do first should be different from what Adams will do. And nobody said we must have to do English first. And we must have to do Lekki Headmaster first. And we have to do comprehension first. Nobody said that. If my best subject of the 4 is physics, I'll go there first. And then what will I do? I will start with that. And if I start that, what would that do for me? It will give me that spirit of confidence. But if I'm starting getting it, then that joy will be there. Something will be secreted in your body system. It's a special hormone that I don't blast. That is the meaning. But if your first order you open, you are confused. Number 1, so the following is true. Of conflagration of metal. Conflagration. Okay. Number 2, of the following anonyms. Okay. Molotiwa, you're in trouble. And that's why you go for the subject that you love most. 1 year, World Cup. Cameroon went to World Cup for the first time. The first football match they will play was against France. And France was the defending champion. So the whole world wrote them away. Was it France? I think it should be Cameroon or Senegal, sorry. Senegal. First time in their World Cup. You know, Cisse, one of those great players at that time. And then, what did they call? First time. People are saying, oh, France will roast you. France will kill every one of you. And to the shocking image of the world, Senegal beat them. In that France team, there was one of the greatest players in the world, Zinedine Zidane. That guy was there. They beat them. Platini was there. They beat them. Senegal for the first time. What does that mean? Because those guys now, their spirit was high there. That year that they went to World Cup for the first time, they entered quarterfinal. First time. They went second round, they are knocked out. But this is the first time. That same year, Nigeria went to the World Cup. We lost our first match. We played draw against Korea or something. Before it was now, that same round, we just came home. That's the end. Other year, we've been doing well anyway. But that year, because the first match we played, we lost. And that affected us. So, in the exam hall on the exam day, is my biology the best subject? Not save time from biology. No. It's not about time. It's about who the one you can easily get some score. We're not saying you finish it. They didn't apply to a math student. Okay. My biology, I will save time. We know. But it's not about saving time. It's about how many are you sure of getting? Because the more you get the questions, the greater your joy, the better your reasoning. That is the meaning. So start thinking of the one you will do. Because one day I will ask you to stand. And I will tell you, you will tell me the one you will do first. God helping you. By the grace of God in the exam hall, I plan to do chemistry first. When I'm through, I go to English. Oh, no, Mr. Adams. I plan to do my English first. When I'm through, nobody is saying you should not do English first. I plan to do English first. When I'm through, I'll go to this one. Like that. Not in the exam hall, you start changing. No. Start thinking of the one to do first. And the one to do first is not you go and ask 4 people, which one will you do first? Chemistry. What about you? Chemistry. What about you? Chemistry. It's as if you all know my mind. My own tune are chemistry. I'm not saying that. Be a woman or a man of your own mind. All of you want to start chemistry, no problem. Me, I'm starting my English. When I'm through, I've been used to starting with English, so I don't want to change. Why not? Nobody is saying this is the method. Do biology fair. When you save time, go and add it to chemistry. No. It's not about rushing. It's about which one can you get high score. And then you are excited in the exam hall. Michael, class, can you help me clap for Michael? Everybody, clap. Thank you. I just told him about this question this morning, very late, and he got them ready. That's high efficiency. That's the type of people that are working for me. Clap for us again. We appreciate it. Okay. Now we go to number 1 again. So we have lead nitrates, PbNO3, lead nitrates, and then we have ACl. Now they didn't give you equation, but you must learn to balance equation. What are you going to have? Exchange of wives, double the conversion reaction. Lead what? Chloride. Don't forget, because lead is divalent 2 plus what? There must be 2 here, Abby. But then put 2 here. See, if you don't write the equation, you have already missed the question. Because you won't know which one is the limiting reagent and which one is the excessive reagent. Can you see the 2 of them? Automatically, you don't expect them to have the same number of moles. Because this is 1:2. So, because this is 1:2, and they gave it the same value of them. Look at that. 20 ml, this one. I mean, this guy will be your limiting reagent. Yeah. It is this one you must use. So why? Because if this is 1:2, I expect my own value. So people are not listening. Okay. I was trying to save time before. But let me do it. Number of moles of lead nitrates. What's the number of moles? CV over what? What's the concentration they gave you? 0.1. What's the volume? 200. Over what? 0.000. So what's the answer? 0.02 Abby. Moles. The same thing, no? Number of moles of ACl. Because they gave you the same thing. CV over 1,000. We don't have to waste time. But let me show you. That's 0.1 times 200 over 1,000. That'll be 0.02. Class, look up. Do we have the same number of moles in this reaction? Who has ratio 1? Lead nitrate, Abby. Who has ratio 2? Now, if I have ratio 2 and you have ratio 1, are we expected to have the same number of moles? My own number of moles should be more than your own, isn't it? Because this is 1:2. but they now give us the same number of mole. Your number of moles should be 0.01. Do you agree with me? Because we are 1:2. 1:2. So we cannot have the same number of moles. So your own should be 0.02. My own should be your own should be 0.01. Half of my own. See, 1:2. That means I won't use the value of this guy. It's too much. I will use only this one. So I'll now come here. Now ACL I go use. Is it lead chloride you are looking for? So I will now use this one. PbCl2. I'm not going to use this one. It's too much. It's excessive. This is the one I will use, limiting reagent. So I'll now say 2 moles. See it here, 2 moles. Give us what class? 1 mole. Then what's the value that we got? 0.02 mole. Don't worry, I'll be doing a lot of stoichiometry for you. I got on Thursday. You have challenges with that. So do like this. But don't bother yourself too much because only 6 calculations will come out in your Jamb. And only 1 will be on stoichiometry. Yes. That doesn't mean you should not know it. Only 1. You know, but this is old school. That's why you have some many of them. 2x, 0.02. That doesn't mean now only 1. So we cannot know I'm no. You examine CPT. That means it can be random. Moles. Oh yeah, let's find molar mass of lead chloride. Who has gotten the molar mass of PbCl2? 27, so that we don't waste time. And that's the number of moles. Number of moles. Mass over molar mass. I mean, the answer may likely be 2.78. That's it. Oh. If we get that one, that means you are solid. Yeah, some people are solid. They are smiling already. That's good. The gases are there. They are not smiling. Want to Joshua? So we want to get 5.56. You are wrong. Majority of that what you got. Gram.
This one is 0.02. And this one is 0.04.
This one is
0.02. And this one is 0.04.
Yes. If this is 0.02 and this is 0.04, then they are both correct. So you can use any of the two. Because this is 1:2. She'll get 1:2 means we must have 1:2. If we don't have 1:2, it means the one that should be ratio 1 should be 0.01. It should be 0.01 and 0.02. But because it's not 0.01, that means its value is too much. And we don't use U if you are excessive. Is that clear now? Any other question on that number 1? It's not about rushing, finish fast. No, it's about you learning. No, I will give you holiday on Monday and Tuesday. That's what government said we should give you. Man, I don't want to give you Tuesday before. Stop saying thank you, sir. Better sit down and read. There's one to thank me for. Better sit down. Some of you are not Muslims. Better stay back in the hostel and read. Exam is here. You can see I intentionally don't want to be writing 30-something, 20-something again. So that you will not be under unnecessary pressure. I intentionally didn't want to do it. Because of holiday. You love me because of holiday. How are you supposed to know that we have to think about limiting reagent or excessive? When you are given value for the 2 things on the left, that's the reason. If they give you only 1, say 0.01 mole of ACL, blah, 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 they didn't mention this one. Gave you this one, then you go straight. But they gave you the 2 of them. Exactly. They gave you the 2 of them. But you have to use only 1 of them. So we're going to see more examples on that. If they give you only 2, the 2 of them, find out which one is excessive, which one is limiting. One question can deny somebody admission. No? So you're going to be saying, now only 1. No, 1. Many other students were denying our party for getting 299. They wept. But some of them are my sons and daughters. Wept. So should I still come? I said, never. Yes. I told them. They felt the pain. My wife said, can I consider 2 nights? I said, no, no going back. So 1 mark can be 1 question. Go and ask some people. They miss unilag admission, 0.3, 0.2 UI, medicine, 0.2. They gave them biochemistry. From medicine to biochemistry, because that 0.2 may come from 1 question from any subject. So every question is important. And every topic is important. No, I don't know that one. Let me concentrate on the one I know. No, try and learn it. Number 2, 56 cm go with gas at STP, weight 0.11 gram. Everybody should get this one. Abi, number of moles, mass over what? Over molar mass. And that's volume over what? GMV, gram molar volume. What's the mass that they give us? 0.11. What's the molar mass? Unknown. What's the volume? 56. What's gram molar volume? Cross multiply 56x with 0.11 times 22,400. Our x, what will it be? 0.11 times 22,400 over 56. What do you get? That's carbon dioxide. That'll be 44. Vapor density, non-molar mass. Okay, so people got 44, they stop. That means you are wrong. Oh. So vapor density now, we divide by 2, are we? Okay. So it's 44 in the option. That's why you have to be careful. Because some of you thought it's 44, you ran away from the. So I've gotten it. So be careful. That's the answer. 22. That number 1 that we have done now. Find time again. Do it around that time. So can I have extra question? Do you still have extra? Of course, we won't sell extra question for you. Give you. You'll practice it again around that time. Can I have the extra, the one they did the other time? We'll do it. So the following gases we diffuse fastest. Now, according to Graham's law, the rate of diffusion is inversely proportional to the square root of vapor, and that's inversely to the same thing as molar mass, molecular mass. So we start finding them. The one that has the biggest mass will have the smallest rate of diffusion. Then the one that has the smallest molar mass will have the highest rate of diffusion. So unfortunately, some people don't know the formula. Can't say propane. From taking the formula propane. So people don't know formula. You don't miss out. Prop na 3. And Amos has started teaching you, but don't worry. You'll soon get started doing those things. So propane, that's propane. 36 plus 8 is how much? 44. 44. What's the P? Oxygen at 32. Abi? Oxygen, O2. So molecular mass now 32. Can leave the vapor density, make it just molecular mass. What's C? Methane. Methane and CH4, Abi? Methane. CH4. So how did they get all these things? Don't worry. The next organic class. Tomorrow is Wednesday. And so Mr. Amos will likely get to all this one. So CH4. Molar mass 16. What's the last guy? Ammonia na 17, Abi. So what's the answer? Methane. So I'm going to miss it too. This 17. So the one that has the lowest molecular mass will have the highest rate of diffusion. Methane. Methane. Number what? Which of the following will have its mass increased when heated in air? Look at that. If you heat me for air, will my mass increase? What they are saying? Class, look up. If you burn helium in air, you burn this helium for air, the guy will still remain as helium. It will not react. Why? The guy that's a very stable octet configuration. That's number one. It's a noble gas. The guy will not react. So helium will remain as helium. So the mass will not change because now helium may remain. What's B? Magnesium. You burn magnesium for air. For air. The guy will react in two ways. Number one, to give you magnesium oxide. So the mass has increased. Not only that, the guy will also react with nitrogen. I'll give magnesium nitride. You know. So the guy will pick something and the mass will increase. You can balance that up on your own. So the answer is magnesium. Because the guy will have something combined with it. Mr. Copper pyrite. Copper, if you burn it in oxygen, there will be no reaction. The guy is below hydrogen, so there will be no reaction. Glass not going to react with oxygen. Can even break and give us silicon dioxide. There will be impurities. So the answer is magnesium, B. Because it will combine with oxygen to form this, combine with nitrogen to form magnesium nitride. You can balance that. Copper, heated copper. This is not copper pyrite. So heated copper is the one that will absorb oxygen. Copper pyrites. What is the formula for copper pyrite? Yeah, that's it. Copper pyrites is an ore of copper. Can I have something like this? So by the time you apply oxygen to it, you're going to have ordinary copper. See, if you like, go and find the mass of all this jargon. The mass of this jargon is very big. Let's say, don't need to add it. Let's just say it's 100. By the time you finish the reaction, you're going to have ordinary copper. You have iron oxide. You have sulfur oxide. This one and this one. What will happen to this mass? Will this mass still remain as this one? As it increase or reduce? Reduce, that's it. So if we apply oxygen to this one will break down and give you all those gases. It will reduce. So the bigger mass will turn to smaller. They said will increase. That's what they are saying. As in which of the following will increase when heated with oxygen? Those one will reduce. Your child has been teaching you now various ways of getting metals, extracting metals. Highly reactive one, electrolysis. Less reactive one, you have to do reduction using carbon dioxide or heated coke. And then the other one that are below, you bring them out because they are found in uncombined states. Okay, so the answer is magnesium. Number 5, what is the temperature of a given mass of a gas? Nobody should be missing anything. Boyle's law, gas law, Charles law. As you are solving, the one that is still not clear, asterisk kits. Go to textbook, check something. Come back, Mr. Adams, this one, when I check textbook, I got 7. Oh, they got 7. Yeah, why did you get 2? I will explain. Meet people also, discuss it. 5. What is the temperature of a given mass of a gas? Initially at 0. That's T1. 0 now 273, Abby. Are we given pressure 1? How much? Now atmosphere. What is the temperature of a given mass of a gas at initially at this and this? The pressure is reduced to 3 atmosphere. Okay, now T2 we look for. What's P2? 3 atmosphere. This is pressure law, Abby. So if you reduce it by 3, then go reduce U2 by 3. So that's 91 Kelvin. Abby, is 91 Kelvin there? That's it. So P1 over T1, pressure law. P2 over T2. Pressure 1, 9. 273. Pressure 2, 3. All of our unknown. Don't waste time on any question. 92. 273 times 3. T2. 273 times 3 over 9. 3 here, 1 here, 3. The answer is 91 Kelvin. Is that the answer? Number 6. Another lesson in the exam, or don't waste time on a stomach question. Those I have solved this one before. If I don't get it, I will not go to the next question. Omo. That's stubbornness. Want to get here, Number 6. In the diagram above, the mixture of the two solid. Look at the two of them. The two solid. They have different what, everybody? Solubility is on the board now. See solubility there now. Which one is the boiling point again? They have this, they put solubility here. Can't talk of boiling point. Solubility. They have different solubility. And when you have different solubility, we have to use fractional what? Crystallization. Don't go and pick distillation, no. Nobody give you boiling point. Where do you see boiling point? Where you pick? They put solubility for you. Once you have different solubility, then we have to use fractional crystallization. Not crystallization, fractional, because there are two different solids. If it's only one solid now, can use crystallization. Number 7, some people say, calculation again. See, all those calculations that you don't like are some things that some people love. And that's it. Oh. A mommy then bring them. That's my own interest. Number 7, magnesium, solid, plus 2 HCl, aqueous. We have magnesium chloride, plus hydrogen. From the equation above, the mass of the magnesium required to react with 250 cm cube of 0.1 molar HCl is, look at that, number of moles of HCl, CV over 1,000. What's our concentration? 0.5. What's the volume? Over how much? What do you get? 1 to 5 moles. Look up, look up. Cloud, what do you say we should find? Check. Mass of, look up. Because you're looking for mass, just like this. Look up, just like this. Magnesium, 24 grams. So where do you get that one from? The atomic mass of magnesium. How many moles do you hear? 2. See it. This official. Don't touch that one yet. 2 moles. How much mass? X. Number of moles, 0.125. That's all. That's all. You have 2x, 24, times 0.125. Our x, what will it be? 24 times 0.125 all over 2. What's the final answer? 1.5. That's it. So I use different method. It doesn't matter. But I use different method and I got different answer. Then you are wrong. Number 8. Go back to the question again. Find time. One year, I refused to go to matric for Unilag. I've not missed Unilag matric because Unilag is the closest to Adams College. And I will teach in Jamb class and I will still go to Unilag matric because I was then return in the evening. So I lose nothing, unlike other schools that, like you are Ilorin and all those ones, you know. When I went to University of Benin for matric, I have to fly, use aeroplane. I have to pay the flight ticket for the photographer. I have to do that and then return. That was a lot of money now and all that. But lag is very easy. But one year I didn't go to lag. So why? We are prepared for Jamb like this. Bang, 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 bang. 2017. I can't forget. And that year, Jamb started their CBT exam. And then they brought 2013 Jamb question in 2017. 2013. They repeated the question. They repeated it. Then come and see those people that were lucky, that have done past question a day before, that have done past question. They come pass. Pass. And then many students that have been reading like mad. So they did not get, they never knew that they said only 2013 question or 2014. So they pass. That year again, then I said, we cancel post-jam. They now cancel post-jam. Then those who now enter school that year, I'm sorry to use the language, most of them were average students who were lucky to have studied 2013 past question. And there was no post-jam to even stop them. Just enter. Then all the best students in Ghana who have been reading like mad people that didn't solve past question of 2013, no admission. So I was protesting that year I won't attend matric until I didn't attend. You go to my office now, you'll see you like matric album 2012, 2013, 2014, 15, 16, 18, 19, 20, 21, 24. 2017 wasn't there. That year I refused to barb my hair. Yes, I left it, protesting. Then, but when the year come, they scratch me. Nobody told me to bring it down before I brought it down. But I wasn't happy. I didn't go for matric. Many boys and girls were dumbfounded. But some people were celebrating as it is sweet us. Those ones that studied 2013 were just celebrating. They were angry that I didn't come for the matric. I said, I'm protesting. That solid boys and girls were left behind. And that's why sometimes all this one we are doing, take it serious. This is a past jam question. No? They said this one mistakenly, and you know if you get them. They say, ah. Some of you can still not get it. Number 8. But your own matric, because I will attend it for you. And when I come to your school, you will not be missing that school. For example, we'll be missing. Say, where is that girl? I think she shows UNN. Where is she? Now 1 mark. Other that boy, I thought she shows footer. So he didn't make it. That's why you have to make it. Work hard. 8. A gaseous metallic chloride, MCLS. No noise in my class. Consists of 20.22% of mass by mass. What is the formula of the chloride? Now, there are many ways of doing it. You can just do empirical formula. Do you know empirical formula? MCl. Oh, is it back way? Not true. Oh, shit. Shit, call. 20.22. Remove this one from Monday. What do you get? 7.8. M now how much? Divided by 20. This one how much? 35 points. Divide what you get? 7,489. Divide this one, what do you get? 2,4. Divide by the smaller ratio, Abby. Over 0.7489. 2.2473. Over what? Is that 1:3? 1:3. How many guys could be MCl3, Abby? MCl3. See, what smart girl would do. Smart boy and smart girl will not solve it. And say 27. Oh, man, that's aluminium now. That's aluminum chloride. I'm making how they solve. Now 3 go there, yeah. That's it. They expect to be smart. 27. Is a risk. But that is going to be the answer. For it to be 27, aluminum now, and that's aluminum chloride. I'm on a AlCl3. That M na Al, Jare. 1 ton around money. Don't go. Number 9. The following are water molecules in the most disorderly arrangement. Moving about disorderly. That's gaseous, Abby. That's ice at steam, Abby. Is it ice or steam? Steam. At where? 100. That's like D. Not water. The guy in steam doesn't move everywhere. Because it's in gaseous form now. Abby now. That's it. Disorderliness. So people pick ice. Ice is in solid form. And the molecules are together. It's the most disorderly arrangement. That's steam. Shamaka, what would you pick? Ice. What? Water at 100 is not yet steam. Okay? It's not yet steam. It's still water. It's still in liquid states. Exactly. Water at 100 is liquid. Steam at 100 is gaseous. And under entropy, gaseous are most disorderly. Number 10. Look at that word. In order to remove an electron from remove one electron from a 3s orbital of gaseous sodium atom, about 496 kilojoule per mole of energy is required. The energy is referred to as ionization. The answer is B. To remove ionization energy, to add electron affinity. Let's go 11 to 20. 11 to 20. 10 minutes. Quickly, quickly. Mokai. You know, they 11 to 20. I see all these 11 to 20, no calculation self. Now only one. And that one self, we go use 1 hour, solve them. Trust you. So try and clear all this one. This one looks simple. 5 minutes more. I'm sure some of you have skipped that calculation there. Want a bear? Jump and pass. I trust you. One for gutter. Then jump gutter. Emma Dami Duro. Then jump arm. One minute more. Three minutes. It's 16 seconds. Number 17, that you jump. Go and do it. Destiny, you need microphone, and she's home. Okay, let me try the number 17. You have jumped it. Try it now. What do you get? 47 seconds. 28 seconds. Ten. Okay, time up. 11. Nitrogen obtained from the liquefaction of air has a higher density than that obtained from nitrogen containing compounds. You know, your child taught you that. Say air. In this air, we have the olorioko of air in terms of percentage. This is most abundant. But the guy is not active. Now, Mr. Oxygen is the most active. Most active. Then we also have some strange materials here, CO2, water vapor. And there was one guy that we can remove the CO2, pass them over alkaline solution, CO2 will be trapped. Pass this one over calcium chloride, it will be trapped. But this guy here, noble gases, you cannot remove them. Noble gases or inert gases, they are just here. You can't trap them. So when you are producing Mr. Nitrogen, this one go. This one can be removed. This one can be removed. But this one will not go. This one will not combine with nitrogen. Nitrogen that should have been less dense compared to what we are having, the guy will now become denser because this one is still part of the air. So the reason why nitrogen in the air obtained through liquefaction is denser than the normal nitrogen in the lab is because of this guy, noble gases. So the answer is D, Abby, because the former contains rari. 12. The method that can be used to convert, have you done hardness of water? You've not done hard water. You've not done water at all. The liquescent, hygroscopic, but you have done solubility. Okay. All those topics that I have not done, I will discover with strategy. The teachers have to do them. I'm sure they will do them. So they will teach acid, base, and salt, water, and possibly you'll do it. At least you are doing revision now, so no problem. The method can be used to convert hard water. Hard water is the water that will not lather easily with. And what do? We convert the soluble calcium and magnesium salts to insoluble form. That's all. I don't want to start teaching you because I always like a child to give it to you the way it should be. So the hardness, temporary, permanent. And this guy is calcium hydrogen carbonate. Have you now? That's the cause. And this one, now calcium sulfate or magnesium sulfate. Sometimes calcium chloride can be there and magnesium chloride. They are the soluble salts. So what do we do to remove them, convert them to insoluble salts? That can be done for this guy. We can even turn this guy by eating. But then I apply it to this one, it turns to calcium carbonate. That's why you have the fluorine or the kettle. The kettle become brownish. Some that use some certain kettle to boil water every time. You see some brown stain at the base. That brown stain is coming from limestone, gotten from decomposition of this guy. You cannot apply it to this one, they will not break down. So you have to use what you call ion exchange resin. You convert the soluble salt to what now? Insoluble. That's it. So the answer is the ion exchange resin. C, the one they will teach you. 13. Yeah, chlorination does not remove hardness. What chlorination does is to what? Sterilize the water. It kills the germs. It kills the bacteria that is in water. You know. But to remove hardness, you can also use sodium carbonate to remove the hardness. Okay. You can use the ion exchange, as we have said now. You do ion exchange. You can apply it to that one. Oh yeah, let's go. Number 13 and 14. The element that is likely to participate, covalent bond. If you're in group 1, what do you want to do? Electrovalent. Group 0, you no go do any bond. Group 0, that is you no go do any bond. Group 7, electrovalent. You like to gain electron. So the answer is group 4, Abi. X for X-ray. So the answer is C. The least reactive element is Z, Abi. Because in group 0, you no go react because you are in group 0. I expect to get those 2 questions without missing anyone there. 1s2, 2s2, 2p6, 3s2, 3p6, 3d7. That D block is not filled up, Abi. We expect to have 3d10, but the guy is not filled up. That means you are D block. That's transition. Once the D orbital is not filled, then you are transition elements. You have a partially filled D orbital. Number 16. Given that electronegativity increases across the period, increase like as are going, you think they increase across the period and decrease down the group, decrease down the group. In which the following compound will the molecules be held together by the strongest hydrogen bond? The answer is A, hydrogen fluoride. Have you? God, the guy is here. See where it is. It increases like this. No, can't decrease like this. So this is the guy that is. Fluorine is the most electronegative element because of its small size. So the answer is A. Anti-jump 17. 0.25 mole of hydrogen chloride was dissolved in distilled water and a volume made up to this. 15 cm cube of the solution required 25 for neutralization. Only going on the alkaline solution. Hydrogen chloride. This one is very simple. I don't know why you cannot solve it. All the jargon they gave you at the beginning was your CA, isn't it? That's your CAO. Number 17. Let's find concentration of the acid. Concentration of the acid. You can say CV. So why you not say over 1,000? Because the volume was in DM cube. See that 0.25 mole of hydrogen chloride was dissolved in distilled water and the volume made up to that's number of moles. Concentration. Number of moles. CV. Then concentration will now be number of moles over B. Because if something is in DM cube, that's why I did it. Claire, what's the number of moles they gave us? 0.25 moles. How much volume do we have? 0.5 DM cube. So what would that give us? 0.5 mole per DM cube. That's the concentration of the acid. That's all. That's your CA. Now, the next said, if you didn't see how the solution requires of sodium carbonate, so you have to write the equation again. HCl, aqueous, plus sodium carbonate, aqueous, we have sodium chloride, plus water, plus CO2. You have 2 here, you have 2 here. So I did not write the equation, so they will miss it. As a CAVA over CBVB, number of mole of acid, number of mole of base. What's the concentration of the acid? Oh, yeah, check. How much volume of the acid was used? Are you sure? You know, the solution requires this. 15. What's the concentration of the base? Unknown. What's the volume of the base? 12.5. What's the number of mole of the acid? Base. 2/1. So I have CB times 12.5 times 2. Now 0.5 times 15. Our CB, 0.5 times 15. All over 12.5 times 2. Calculator, what do you get? 0.3. Some scholars got it too. But Dija, did you get it? Zainab 2. 0.30 mole per dm cube. '18. The correct order of increasing oxidation number of the transition metals. This is simple, Abi. This one is potassium heptadichromate 6, vanadium 5 oxide, potassium tetraoxomanganate 7. So the smallest is what? Vanadium 5 oxide, followed by K2Cl2O7, followed by KMN option. But those that didn't know it, I'm not in a hurry. I go do them. K2Cl2O7. So you have 1 times, so potassium is 1. You have 2x minus 2 times 7 equals 0. So now I have 2 plus 2x minus 14 equals 0. 2x minus 12 equals 0. 2x equals 12. X, 12 over 2. What's your x? Plus 6. And then vanadium 5 was at V205. That's 2 times x minus 2 times 5 equals 0. 2x minus 10 equals 0. 2x equals 10. X plus 5. Vanadium 5. So I'm not in a hurry. Some people may not get that. Then KMnO4. Potassium, now 1. Manganese, now x minus 2 times 4 equals 0. So you have 1 plus x minus 8 is 0. X minus 7 is 0. S is plus 7. In order of increasing, 5 is the smallest. So answer will now be V205. That has 5. Less than K2Cl2O7. That has 6. Less than KMnO4. That has 7. 19. The set of pollutant that is most likely to be produced when petrol, look at that word, petrol is accidentally spilled on plastic material and ignited. Now, forget about the plastic. When you apply it to petrol, the normal thing should be forming CO2 and water. Because petrol is a member of the hydrocarbon. You know, your child was going to teach you petroleum. Petrol is also called the gasoline. Petrol, when the guy is oxidized or combusted, rather, give us CO2 and water. But incomplete combustion of petrol, what will it give us? CO, carbon 2 oxide. That is very dangerous because that combines irreversibly with our hemoglobin to form carboxyl hemoglobin. So naturally speaking, CO2 is one of the answers. So any option that has no CO2 is out. And if you look at it very well, all of them then get CO2, 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 CO2. And so B is, so if you pick B, sorry for missing it, but B must be there. So the pollutant that is most likely to be produced, most likely, when petrol is accidentally spilled on plastic. Now, what are the components of a plastic? A plastic will also contain chlorinated material. That's why HCl comes in, called a plastic. So HCl will be part of the answer. HCl, CO2, and sulfur 4 oxide. That's the answer. So where is sulfur coming from? Many petroleum contain sulfur. Many petroleum contain sulfur. I'm going to contain sulfur. We are going to have SO2. I would have loved to have CO because it will not be fully, it may be partially combusted. We have that. So let me see if I can eliminate something. The set of pollutant that is most likely to be produced when petrol accidentally spilled, when petrol is accidentally spilled on plastic material and ignited, HCl must be there. So don't say A is wrong. So I'm going to have CO2. That is compulsory. I'm having between C and D, CO2, HCl, CO2, Cl, CO, that's partial combustion, and SO2, petrol that is having sulfur as impurity. I think I will still stick to my D, SO2, CO2, and HCl. So why? Because most petrol in the world contains sulfur. That's why our Nigerian petrol is one of the best petrol in the world. Why? Sulfur free. Sulfur free. But unfortunately, our refinery is not working. Thank God to Dangote. Do you know what Nigeria was doing? We'll bring out petroleum products from our soil. We will import it to other country. They will help us to refine it and send it back to us. And we'll pay money. Yeah, a lot of money for the service. That's how bad it was. So this is a better answer. That C is partially correct too, but I think I will go for D because of the sulfur. Many petrol in many countries contain sulfur, and some plastic also contains sulfur. So where is chlorine coming from? From chloroethene. Chloroethene that we have in plastic. You also meet of PVC as well for making pipe. Contain chloroethene. Which answer? I didn't give you anything to do at the back. So number 19, I think we should go for D. But I love that C also, but we go for D. D is more appropriate. Number 20, what is observed when aqueous solution of HCl4? Look at that. H2SO4. You may not know something. Look up. Plus waiting. Potassium. Triazole. Like this. KiO3. And what again? Look at this. This is a very simple question. What do? Form equation. Exchange radical. So how will I exchange radical? Look at the board. Potassium there here. Potassium there here. They'll go for the anion. They can't stay with this guy again. This is only anion there. They'll come and meet him. And the two of them will come. We are joined together. Yes, sir. We are K2. We are joined this one. SO4. What happened again? Hydrogen can't stay there. They look for what to join. Mr. Hydrogen will always pick oxygen and come to what? Water. So we go pick oxygen from here. And you're going to have H2O. After turning water, one guy is left behind. See him. Iodine. That's it. That's all. Can balance the equation yourself. Can put 3 here and put how many hydrogen? 6. Put 3 here. Put 3 here. Just balance it as you like. How many potassium? 6. 18. 3. Anyway, my own product, I may not put the 6 here. Try and balance the equation yourself. What are we having here? Iodine. So that's the answer. Iodine is produced. So go and look for any option that has to do with iodine. Option A. Why precipitate is formed? Never. Sir, is this guy why precipitate? Never. Anything potassium is colorless. It's what, everybody? Potassium, sodium, they are colorless solution. So that's A is wrong. Option B. A green precipitate is formed. Green care. This guy, potassium is always colorless, no green. Option C, the mixture remain colorless. That's not true. Yes, that's not true. Because this guy is colorless. That's true. This one is colorless. What about this one? The mixture turns reddish brown. That's the answer. God, the iodine. This is reddish brown. Reddish brown. Reddish brown. But the interesting thing is that the reaction is not balanced here, so find time to balance it. But that's the products. Let's go now. Number 31 to 40. This one no get calculation, Abi. So 5 minutes, 31 to 40. No calculation, yes, check it. No calculation. No talking. I know you are getting tired, but don't talk. Sustain the momentum. No talking. No talking. Try to balance this equation. It should be 5. Three. 15. 8. Potassium. H2SO4. 16. 4, 5. We can put 5 here. 3. 6 hydrogen. 3 here. Potassium 6, 3. Iodine. 6 iodine 3. Well, it's difficult to balance. 6 iodine, 6 sulfate 12, sulfate 12, 6 hydrogen, 6 hydrogen. Correct. So that's iodine solution. Not talking. 2 minutes, 25 seconds left. Now 5 minutes I give you. If your neighbor is not serious anymore, ignore them. You concentrate. A minute, 10 seconds left. There's no calculation, so this one shouldn't give you problem. Time up. 5 minutes is not much. Those who are saying, I don't like calculation. Now, calculation no there now. I don't like calculation. They can't give you 10 where you no get calculation. You can't complain again. I'm going to one more look at it. One more look. Make one question there, we get one more. So be a balanced student. 31. So the following statement is true of the electrochemical series. Electrochemical series. Electropositivity of metal increase down the series. Is that correct? Electropositivity of metal increase down the series. Is that correct? Is that correct? Some people said yes. Who are those that said yes? Raise your hand. Let me see those who are courageous that say yes. Okay. Thank you for saying rubbish. The fact that you are courageous doesn't mean you get the answer. You can have courage. Like the man that went to the lion's den, he has courage. Lion finished him. That's negative courage. Don't forget, how can you say that? See, there's a chemical series for metals, magnesium. As we're going on like this is the most reactive. So electropositivity decreases down. So that here is wrong. Option B, electropositivity of non-metal decreases down the series. Is that correct? It's wrong. So we pick it, you are wrong. Say electronegativity of non-metal increase down the series. Is that correct? The answer is D. Of metal decreases. As we are going like this now, the thing they decrease. Okay, I want to give you some important thing, but I don't think I have time on this series. Okay, maybe later I will try and give you something on that. Some of you don't know it. Some trends, some important trend. Electropositivity, can see, is decreasing. Potassium is more electropositive than copper and all those ones. Number 32, the gas that will form a white precipitate as it defies silver 2005. Now, look up and stop noise. Test for chloride. I'm sure Mr. Victor has taught you. You react silver plus chloride ion. You're going to have silver chloride. There is a white precipitate. Insoluble in HNO3. Insoluble in HNO3. Soluble in ammonia. That's the test for anything chloride. whether you are a gas or an ion. That is it. So anytime you react anything silver nitrate with chloride ion like that, you're going to get a white precipitate, insoluble in HNO3 or soluble in ammonia. So look at that, number 32. The gas that will form a white precipitate with acidified silver nitrate must have chloride ion inside it. So that's a D, ACl. You know, that stands for chloride ion. 33. Listen to me. This question. Many textbooks in the world miss it. Many past questions, I've seen many times. Many past questions miss it. And many of you, I know you have crammed the answers in those past questions. You go miss them. If you go to Google and check answer, you will see miss it. Many of them pick wrong thing. Yeah. If you go to all this one they call, is it something like school something? They miss it. They are now asking for comments. You will miss it. Look at that. Chlorine, bromine, and iodine resemble one another in that the answer all of them picked till tomorrow is what you are going to pick. Many of them went to pick D, you are wrong. Display one another. Never. Never. It's not resemblance. That's not resemblance. We displace each other. Is that what does that mean? The fact that you displace me from a reaction, this one displays this one. How do we resemble ourselves? Sodium and chlorine, sodium and potassium resemble each other because they displace hydrogen, they remove hydrogen from. Mr. Calcium will also do the same thing. Mr. Magnesium in another group will do the same thing. Why would they now resemble each other? But see the reason why we resemble ourselves. Chlorine plus water. You are going to have also chlorate 1 acid. And what? ACl. Bromine plus water. We are going to have also bromate 1. This is what they call resemblance. Plus HBr. That's 1. Our reaction with water. Number 2. Our reaction with what? With base. Chlorine plus sodium hydroxide. If it is hot and concentrated, I'm going to have sodium triisochlorate 5 plus sodium chloride plus water. Do the same thing for bromine. I will give you the same thing. Bromine plus sodium hydroxide, all concentrated. I go dissolve. I'll form sodium triisobromate 5, sodium bromide. And this is what we call resemblance plus water. Therefore, cold, if you now change this one to cold and dilute, Mr. Chlorine plus sodium hydroxide, cold and dilute. I'm going to have sodium chloride, sodium isochlorate 1, NaOCl plus sodium chloride plus water. Mr. Bromine, are you going to follow the same thing? Yes, I will also dissolve. Why? We are family. We resemble each other. Not that I displace you, you displace me, I displace you, displace me. That's not chemistry. Sodium isobromate 1 plus sodium bromide. Go and check all the past questions. That's what they will pick. Don't pick it with them. Plus water. That's it. So the answer is reaction with water or reaction with alkali. So the answer is option A. 34. The salts that react with dilute hydrochloric acid to produce pungent smell. Pungent smell is attributed to a guy called SO2. So for you to have pungent smell, you are SO2. If you have irritating smell, you are also SO2. If you have rotten egg smell, what's your name? H2S. That's it. And that guy was also dechlorize acidified potassium 27. If you pick A, you are wrong. The answer should be B. B. But don't just guess. How? Why? Number 1, the gas must be SO2. Sodium sulfates. They can't react with waiting. Option A, with ACl. So what are you going to have? If they apply it, exchange of bomb like this, what are you going to have? Sodium chloride plus H2SO4, which may not even make sense. H2O and SO2. But it will make sense. This is what you're going to have. Sodium sulfate. The reaction may not even proceed. Sodium chloride. You can balance on your own. What is B? Na2 SO3 plus HCl. You're going to have NaCl, water, and CO2, SO2. That's it. You'll have gotten a H2 SO3, but the gas will break down. It's unstable. And that's the pungent smell gas we are referring to. What of C, Mr. Adams? What of C? What is C? Na2S. Na2L plus HCl. Oh yeah, chlorine can't join me. Yes, sir. Sodium chloride. We don't have hydrogen sulfide. Rotten egg smell. Ayama. That's it. Rotten egg. Option D. What do you D? Na2CO3. This one will give us a what? NaCl, H2O, and CO2. A colorless, odorless gas, Abi, that turn lime water milky. About 10 minutes ago, some students have switched off. If you look around, you see them in all the classes, tired. Give them one of these questions tomorrow again, they will miss it. They are the ones who are not able to endure pain to the end. Tired. I'm hungry. I'm stressed. In fact, now I'm experiencing sheer stress. My shape doing a change. It's affecting my shape. Into flats. Sheer stress. Okay. So the answer now. 35. A pair of compound that can be used to generate a gas which are physiological. That's laughing gas. Effect on human being just laughing without any need. Shaking air without music. We gave it that reaction that time. Oh. There's a guy that produced laughing gas. Ammonium nitrate, I believe. That's it too. And I told you how it is formed. Maybe so. H2O. 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 You can make it 2. 4 hydrogen has gone. 2 oxygen has gone. It remains N, N, and 1 O. N, N, and 1 O. That's it too. This ammonium nitrate. They now said, what can we combine in the option that will give us this one? That's what they're asking. No. What and what we exchange wife and give us this one? What and what we combine? So get all these things done. Don't be lazy. What and what we combine? Let me go back to option A. And that's why we don't want you to get to number 50 and go. But that's not my goal. Yes. What do you mean option A? Sodium 5 and calcium chloride. Look at this. We are looking for the one that will give us this one. And calcium chloride. Can this one give us this one? There is no ammonium there. You are going to have sodium chloride and calcium nitrates. That's what you're going to have. Can't give us this. So A is out. What will be? Sodium what? And what? Ammonium chloride. What will this one give us? Ammonium diosonate 3. And what? Sodium chloride. Is it giving us this one? No. This one has 3. Bang, bang. This is how to produce what? Mr. Nitrogen. Abi, this will give us nitrogen, N2 and 2 water molecule. Let's go to C. What do you mean C? NaNO3 and what? Ammonium chloride, NH4Cl. What are we going to have? NaCl plus ammonium. Is that the kind we are looking for? That's it. Oh. That's it. It's not just cramming. That's what? Some of you may not know it. But if you listen and read it intelligently, you can get answer. I was in the maths class today. I was teaching them maths. And some of them were not offering mass. I just saw them at the front. What were you doing? So we're doing CRK. I said, let me see the question. So, sir, CRK, wait till you know if CRK. I said, the answer is A. Scholar. They call me scholar. Because I got it. Why? Because it's simple. There's some question you can, because it has option, you can easily use your logical sense to get answer. They were still surprised. One can say, nah, because he's a pastor, they go church. I say, you say okay about church. So there's some option you can easily get. 36. Look at that word. Hydrogen is using oxyhydrogen flame. Look at that word. Flame. Flame. What do you want in flame? What do you want in flame? Heat. Heat. So if you don't know it, look at the option. Is it an flame for metal because it involves a lot of heat when burnt. Is that correct? That's the answer. You don't need to be taught hydrogen flame. So they never taught us. So never taught us. It combines explosively with oxygen. The idea that you want to use it, you are going to die. Because when you have an explosive reaction, you cannot withstand. Middle floor. Some of you in the main hostel, they explained that yesterday. You did something strange. That you release gas without putting anything on top of the gas. That's dangerous. I don't know who did that one, but I mean, I don't want to be talking. So I don't say every day we will talk. This gas was on. Like that. That can bring explosion. We talk now. They say now, Mr. Adams, they talk. And some of your parents will now come and say, for 3 days, there was no gas. And you are wasting it. Not even wasting it, even the danger of explosion. Number 37. In the diagram above, what is a mixture of, look at that. They want to produce ammonia. Abi now, that's ammonia they want to produce. Oh. Mr. Victor has taught you all these things. Oh. Want to produce ammonia. Just look for ammonium salt. Abi? And what? And a base. Ammonium salt and a base. That's it. To produce ammonia, you need ammonium salt and a base. Option A, that's a base. The answer is A or B. Write the equation. Some people are sleeping. I can see them. The eyes is closing, small. 35-degree closeness. I'm going to Larry Moshe and see. Calcium hydroxide and what, class? Option A and what? Ammonium chloride. Write the equation. Don't be afraid. Write it. What thing go happen? Calcium join with chlorine. Calcium chloride. You now have ammonium hydroxide. See it? Then this guy will now break down into two. Ammonia and what? Water. That's all. That's ammonia gas. Write the equation. And for every right you are writing, double the composition. Exchange the wives. That's all. Chlorine, go there. Yes. You come here. Yes. This one. Can you give me ammonia? Yes. That's the answer. You don't need to cram. 38. What property of duralumin make it more useful when it's contained metal? What is the major element in duralumin? Aluminium. Listen. If your aeroplane is aluminium made, aeroplane no go fly. Because to be too heavy. So to make the guy light, you have to add some other metals like copper, like magnesium, and manganese. When you add them, the guy will now be very light and still strong. Because if you are light and you're not strong, aeroplane, wind go they blow you up and down. So you're going to be light and very strong. So the answer is stronger. And see, the pair of metal in the reactivity series that are usually extracted. Look at that word. We mentioned it today. Your teacher mentioned it yesterday or Monday. If you are very reactive, we can extract it through what class? Electrolysis. So look for the one that is most reactive. Magnesium and calcium. See, this number 40, your teacher mentioned it today. I had him in the class. So people still miss it. Why? When Victor was talking, they were buying tom-tom in front of the talk shop. Somewhere in the toilet, 10 of them in the same toilet, just talking and gisting. Those we can extract through electrolysis, potassium, sodium, calcium, magnesium, and aluminum, 5 of them. Potassium, sodium, calcium, magnesium, and aluminum. 40. A metal that can be extracted from calcitrides is what? Tin. Tin 4 oxide. Well, let's go quickly. 5 minutes for the last 10. 5 minutes. Those who are saying, the gate is open, so nobody is stopping you. Yeah, 5 minutes. Just take it. 5 minutes. Quiet. I didn't ask you to talk again. You'll be sure whether you have been taught or not. Some students will get that 10-10 for the last 10. So be saying they never taught us. Two 30 seconds. I didn't tell you to start talking, no. No talking. Okay. You are true. You are just saying yes, sir. You don't know anything there. You don't want to go home. Yes, sir. Call. Say yes, sir. But one, which of the following metal is passive to concentrated HNO3? That's the answer. Eh? Ion. 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 That further reaction will be in the called the formation of the layer. That passivity is also what leads to rusting of iron. There will be formation of oxide of iron on top of that. That will prevent further reaction. Not only iron, even aluminum does the same thing. Iron and aluminum. So the answer is iron. Copper, for copper, there is no passivity. We're going to have copper nitrate and nitrogen oxide being generated. So iron, take notes. 42, the hydrocarbon that burns in air with sooty flame. Mr. Amos, I just taught you aromatic and what? What's the difference? I also wrote it for you one day like that too. I don't know whether you saw it. Aromatic, they burn with aliphatic, burn with sooty flame or smoky flame. Burns with sooty flame. I told you. Do not burn with sooty flame. Sooty or smoky flame. Sooty flame. So what's the meaning of sooty flame? Heavy carbonated material, black. I don't know whether you have seen when they are burning tire before. Tire. And that's a flame that comes out. So that if you stay here now and put paper on your head, you see black material there. That's a sooty flame, very heavy. You see the red. And the olorioko of aromatic, he has told you yesterday, is benzene. Benzene. So the answer is D. What of? Yes. But there's no unsaturated carbon there. All of them are saturated. All the three options they gave you, they are all hydrocarbons that are saturated. They are all alkanes. Because you was asking a good question. Some unsaturated hydrocarbon can also burn with some element of sooty flame. But the one for aromatic is heaviest. And if you look at option A to C, they are saturated. They are all alkane family. 2-methyl prop 1 in. Now, if you don't know it, this is what to do. I will count how many carbon we have. Prop 1 in. How many carbon do we have in prop 1 in? 3 carbon. Then 2-methyl. How many carbon do we have in methyl? 1. Then 3 plus 1 is what? 4. 4. Option A, put 2 in. Ask how many carbon atom? 4. So A is correct. Option B, pent 1 in. 5. I don't even, without even drawing. Option C, 2-methyl, put 2 in. Butene. Butene is 4. Methyl is 1. 4 plus 1, 5. You are wrong. Option D, 2-methyl, put 1 in. Put 1 in is 4. Methyl is 1. 4 plus 1, 5. I'm repeating that again. You don't need to draw. 2-methyl prop 1 in. 2-methyl prop 1 in. Propane na 3 carbon. Methyl na 1. So what about these two here? That two is talking about the positioning. So 1 plus 3, we have 4 carbon. Go and check out the one that has 4 carbon. That's what we are saying. Option A, put 2 in. That's 4. Put means 4. So that's the answer. It has 4. And I'm talking about 4. Others, go and check there. Put 1 in. That's 5. 2-methyl, put 2 in. 2 in, 4. Met 1. 4 plus 1, 5. 2-methyl, put 1 in. Put 1 in, 4. Methyl 1, making 5. Option 44. Number 44. So the following is a solvent for perfumes. Option A is C5H12. What's C5H12? Pentane. What's option B? C4H6. Butane called butane. You want your teacher will teach you. What's C? Ethanoic acid. It's ethanoic acid. What's the ethanol? So, Claire, what do you think it is solvent for? What is solvent for perfume? Eh? Aisha Salau. To wait for the mom in the building. Okay, so Aisha Salau, please, if you're around, your mom would like you to wait after this class. Perfumes are what? Esters. And esters are made from the reaction called esterification. Reaction between arachidonic acid and what? Arcanol. For you to be a perf, if they put perfume, see, a good perf should not stain your clothes. A good perf, if you are using perf and everything can stain, it's not very good. Therefore, a good perf must be very, very volatile. So what they're asking is that of these two, which one is highly volatile? And the answer is ethanol. D. No, ethanoic acid, though. Ethanol. Why? This one has a double hydrogen bond. OH and another OH, double hydrogen bond. This one has a single one. There was a question we solved last time that I asked to do with these two guys. So go and check it. One is more polar, one is less polar. It's there. Go and check. Ethanol is a very good organic solvent. We don't use ethanoic acid as organic solvent too. Ethanol, very good organic solvent. Very good organic liquid. Ethanol is also a good preserver of life. Some of the specimens we have in your lab, that's one of the students that will be doing biology practical now. They have some toad or frog or lizard, and they are inside the bottle. The bottle contains what? Ethanol. They use to preserve them. So the answer is ethanol because of its high level of volatility. So people are not noting anything. They're just looking at me. They're waiting for time to go. They are waiting for me to say number 50. Look at this. When it says ethanol is heated to 45 degrees in the presence of the product is now. Look up. There are two reactions. Please, your friends that are sleeping, help me wake them. Will soon be true. I know I'm stressing them. Look at this. Ethanol. Concrete 4. SS. 180 degrees Celsius. Final product 18. But when you have ethanol, conc 804. But this guy now SS. This has been coming every year, most times. SS. This one is SS. So it's going to be SS now. Temperature can reduce to 145 or 140. You are going to have dimethyl ether. Or sometimes you can have diethyl ether. What we call ethoxyethane. That's it. So there are two products now. See, 180 ethene. In many universities, what do? They write all these equations, they put question mark here, fill in the gap. Sometimes they will put question mark here, they will write 18. Question mark here, they will write this one. That means I expect to know the temperature. That's it. So answer diethyl ether, option C. 46. How many grams of bromine will saturate 5.2 grams of both 1 in 3 iron? What a question. Let me do that question for you. Both what? Both 1 in 3 iron. Look up. Both means 4. Sure you know. Both 4. Both now 4. So I'll put double bond here. Mr. That's why. Because they put 1 in. In means double bond. Iron means triple bond. So this 1, 2, 3, 4. Put 1 in 3 iron. 1, 2, 3, 4. Hydrogen here. Hydrogen here. Don't forget, you must not go beyond 4. 1, 2, 3, 4. 1, 2, 3. You put 1 hydrogen to make it 4. This guy already doesn't need any hydrogen. It's already 4. 1, 2, 3, 4. This one 1. That's boot 1 in 3 iron. So how do you get boot? 4 is boots. What are 1 in? Double bond, carbon 1. 3 iron, triple bond, carbon 3. Class. That compound is what? C4 words. C4 words. C4 words. C4H4. Look at the board. C4H4. We're almost through. C4H4. We are reacting with bromine. Now look up. The saturated hydrocarbon in this world, what's their name called? Alkane. Who can remind me, what's the formula for, what's the general molecular formula for alkane? Okay, I'm going somewhere. Now, if you have 4 carbon, C4, and you are alkane, that means you are saturated alkane. How many hydrogen are you expected to have? 10. Put 4 here. 2 times 4 is what? 8. 8 plus 2 is what? 10. That should be C4H10. Now, what are we having here? C4 what? For you to have 10, listen to my grammar. For you to have 10, you need 6 more bromine. Anybody listen to what I'm saying? For you to have 10 and become saturated, you need 6 bromine. So I cannot be C4, H4, bromine 6. So all of you now become 10. So that means I will need 3 of these guys. That's what I will need to make it complete like this. C4, H4, Br6. That would not be like 10. This is 10 now, 10. This guy is now saturated. That's what we are doing. That's it too. Oh yeah, now let's not calculate how many grams of bromine was added 5.2 grams. So this guy now, let's find his value. 12 times 4 plus 1 times 4. So that'll be 48 plus 4. That's 52, Abby. That means we have 52 here. Mr. Bromine, don't forget the 3. 3 is very important to us. 3. Bromine, how much? 80 times 2, Abby. So that'll be 3 into what? 160. What's 3 times 160? 480 gram. Gram. See, look at that. They now give us 5.2 gram. Say 5.2 gram. You're not looking for this one, X. And if you are smart, 52, 5.2. This one, 480, 48. That's the answer. 48. Some people say, sir, do you know what? I got it, but I didn't work it. You are the best in the world. No one like you. You got it. You didn't work it. Something just told me that it should be 48. And my instinct does not deceive me. What do you take? So 48 gram. Olivine chloride, PVC. Is it a porous pipe, Abby? We have mentioned it today. Pipe. 48. An organic compound that does not undergo a reaction with both hydrogen cyanide and hydroxylamine. For you to react with those guys, you must have carbonyl group. You must have what? Sorry, what? Writing, excuse me, write fast. So, reaction with hydrogen what class? If your garri is not well produced, it will contain cyanide. And that's dangerous for your eyes. Okay, so people take a lot of garri. Who cares? There's nothing bad there. I have a jar of garri in my office. So there's nothing big deal there. Now, all the people they think garri is expensive. Hydrogen cyanide and hydroxylamine. Hydroxylamine. That's hydroxylamine. For you to react with these guys, I'm skipping some small note. For you to react with this guy, you must have carbonyl group. That's the name. Mr. Adam, what is carbonyl group? They're like this: C double bond O. This carbonyl group. If you don't have CO inside you, you don't go react with hydrocyanide and hydroxylamine. This carbonyl group. Let's go to option A. What's option A? Alkene. Does alkene have O inside them? So that's the answer. Alkene has CnH2n. They don't get this one. What's option B? Aka. Let me give you Aka now. Amos has given yesterday. C double bond OH. Abi? That's Aka now. You must know the functional group. What's C? Aka known is ketones, Abi. So that's C double bond O. We have, these are our key groups. They have carbon, both of them they have. What is D? Arachidonic acid. Arachidonic acid. Somebody did not know many chemistry, but this afternoon now she has learned, or he has learned some things. And he prays on those things and then get some opportunity to blast exam when the opportunity come. Carbon C double bond OH. I'm trying to emphasize this CO. So once you have this CO, you have this CO, this CO, this CO, you have carbonyl, then you can react with me. hydrogen cyanide. Can react with me, hydroxylamine. 49. When the two end alkyl group of ethyl ethanoates are interchanged. I've taught you before. So when you say ethyl ethanoate, then to come ethyl onate, you interchange it grammatically, you get to do. That's not what they are saying. Ethyl ethanoates. Now say OAte ethyl. So it will not make sense. Look up. I've taught you before. If you want to write esters, you must start the name from the end. From where, class? See question O. C2, H5, COO, C3, H7. If I want to name this one, I must start from the end. Now, what is this place? If you have 3 carbon, what's your name? Prop. So this is propyl. You must count this one. Oh. 1, 2, 3. 1, 2, 3. Propanoate. Say that, everybody. Propanoate. Say that. Okay, name this one now. Let me see. C3, H7, COO, C2, H5. Ethyl buta. This is 3 plus 1, 4. 3, 1, 2, ethyl. I can't hear you again. Say it again. Ethyl butanoates. Let me tempt you now. H, COO, C2, H5. Name this one. What will it be? Ethyl metanoate. You have to count 1. Ethyl metanoates. Okay, we get this last one now. We'll now go back to the question. So if we have CH3, CH3, CH2, 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 COO, CH2, CH3. And that's all. Some people were shouting Jesus. 1, 2, end. Ethyl. 1, 2, 3, 4, 5. Pentanoates. Oh, yeah. I told you about emotional intelligence because you saw C and because you shout Jesus. Oh, yeah, let's go back to the question. What's the question again? Ethyl what? Look at the board. Ethyl ethanoates. Can you draw it now? Ethyl ethanoates. We must start from the back, Abby. So this is ethyl. C2, CH3, CO. Do you agree with this diagram? Ethyl, 2 carbon. But the mention it, you drew 1. No, there are 2. What did they say? They now say they exchange this one. You come over here. Then you go. They say they were interchanged. So what will now be here now? C2, H5, CO, CH3. Yeah, name it now, everybody now. I can't hear you. Is there the option? That's the answer. Mr. Dance, I don't know many things, but I think I got this one very well. That is it. Learn something. Methylpropanoates. Last question. Show the compound above will react to take up 2 molecules of bromine. 2 molecules of bromine during bromination. Mr. Amos will start teaching you addition and substitution reaction. All saturated hydrocarbon, they undergo substitution reaction. But if you are unsaturated, what do you undergo? Addition reaction. Some of this diagram that we drew now, draw it for somebody tomorrow. They didn't teach us. They've not taught us. We have not reached there. Okay, you will reach there. Remember 1. H, C, H, Look at this. Then draw. 1, 2, 3, 4. See there here. H C double bond O H. Look at the board though. I want to explain something. That's row number 1. Row number 2. HO C HO. That's B. Row number 2. This is row number 2. This is row number 1. The last one, row number 3. O C H triple bond H. Look up. When you're adding your bromine, I'm happy that Mr. Amos is already doing this. So by the time you start adding for you, the thing will start making more sense. But now, because this is not the real teaching, it's just revision. Look up. If I have somebody like this is a thing. The guy is not saturated. It's unsaturated. It doesn't have straight chain. And that's on spaces. I will now add one bromine. Now only one, no. The guy will not be like this. All the hydrogen will now stay together like this. These are the 4 hydrogen that were there before. Then the 2 bromine guy, they will now join the 2 carbon. We now have 1, 2 dibromoethane. But if the guy has triple bonds, like Mr. Ethyne, is the last question, don't worry. By the time you add the first bromine will turn the guy, it will remove one of the triple bond and turn it to double bond. The 2 hydrogen will stay here and say we are here. Bromine will now join. The guy will now shout, Omo, I never saturate to go to you. You will now add one more bromine. So for Mr. Ethyne that has triple bond, you need 2 bromine molecules. The first one will turn into double bond. Second one will now turn into single. I'll be like this. We now have bromine, hydrogen, bromine. That's what you have. The name will now be 1122 tetrabromoethane. 1122 tetrabromoethane. Say that. 1122 tetrabromoethane. That's it. 1122, because these guys are on carbon 1. 1122 tetrabromoethane. That's it. Now, how many molecules do we need when you have triple bond? 2. How many do we need when you have double bond? 1. This guy has triple bond. Are you following me? If you have triple bond, how many molecules do you need? So this guy is correct. That's 2. Now, we don't add bromine to the carbonyl group. This is carbonyl group. See, anytime you see CO like this, no go area. Don't come and add bromine here, never. You can only add those guys like what? Hydroxylamine and what? Hydrogen cyanide. I will mention. This is another carbonyl. Never. Don't come here. Class, for this one, how many bromine molecules do we need here? 1. If a double bond, you need 1. So now only 1 we need. Now 1 bromine molecule. 1. How many bromine molecules do we need here? 2. How many bromine molecules do we need here? How many bromine molecules? 0. We don't need anyone. These guys are carbonyl. You cannot have bromine to them. These are carbonyl. Don't come and add anything. And they are saying which of them, look at the question, which of the compound above will react to take up how many? 2 molecules of bromine. So what's the answer now? 3 only. Thank you very much for attending class. 3:22 is when the class is over. Help us put all our shares together so that the hostel student can rest. I've been standing since 7:30. Don't come and line up in front of my door. I want to see Mr.